shipped here from the US. So yeah, I've been playing around with those of late.
So
is that the one you had taken apart? We saw some pictures on Facebook of you tearing it down.
Right. Yeah.
So I'm going to ask you a few questions. Obviously, you know, we want a lot of the listeners have tuned in tonight to listen to a little bit of a history of how you got into astronomy in the first place. What drove you to actually get into astronomy in the first place?
I first became interested in astronomy when I was at primary school. So I must have been around the age of 10, 11, something like that. And it was books in the school library that I first started. I kind of started reading, and I was really amazed by, you know, the photographs in there from Voyager and things like that. And it was those things that really kind of caught my interest at that time, and it kind of just went from there, really.
Yeah. So why did you specialize in planetary imaging? Because I know you do deep sky imaging. I've seen your deep sky imaging, but what made you specialize in planetary imaging particularly?
I think with planets, even right from the early days when I first became interested, I always found the planets captivating. And I think what it is about them is their dynamic nature, in that, you know, they change, and some of them, like Jupiter, are changing very quickly. So unlike galaxies and nebulae, which will look the same throughout your entire life for the most part, with planets, you've got a dynamic changing system, which is, you know, really interesting. And you can also, you know, through a telescope visually, they're also really impressive to look at.
Yeah. So you're involved, or are you still involved with Chilescope?
Yeah.
And
so I've been involved with them for 3 or 4 years now.
Yeah. So why is it you don't get ribbed about remote imaging, but I do?
Because he's good.
Yeah, that's what
Peter knows I love him.
I've had similar comments to, you know, things with regard to remote imaging and it not being proper astronomy and things like that. And it's I don't know where that kind of, I guess some people are kind of stuck in the mindset that the only way to do astronomy is at the eyepiece of a telescope.
Yeah.
And, you know, if we all adopted that approach as a civilization, we wouldn't have really gone anywhere scientifically. I mean, if you think about it, the Hubble Space Telescope is the ultimate remote telescope.
Yeah. Not many people at the eyepieces of that one.
Yeah, exactly.
Well, there haven't been people at the eyepieces in observatories for decades.
No.
Yeah.
You know, so I think it's quite ridiculous, really. I think it's jealousy more than anything else, to be quite honest.
Sometimes I think it's the guys that have been playing musical chairs with their kit for so long and finally realize that maybe this next guy ain't going to buy it from him and he's going to have to sit with that one. So he's got a natural bias against it.
So do you still go out to the Barbados and that area to do any imaging?
Yeah. I'd actually, it's an interesting story. I'd actually planned to go a few weeks ago, and I was actually booked to fly out. But unfortunately, I had to cancel it all at the last minute due to virus restrictions. So yeah, that was a bit of a bummer. But yeah, absolutely, I still enjoy going there.
Yeah. So what I'm going to do, I'm going to open it up to let the guys in the chat room ask you a few questions. I know Kath's got a few to ask you. I'm certain Kath's got a few to ask you.
I don't know what you mean. I don't interrogate people.
Off you go.
Okay. Well, I was going to ask, obviously, Mars at the moment is the thing that everyone is looking at. And as Peter's already said, your images are stunning. You posted one today, wasn't it, that you took on the 17th, which, I mean, the detail on that is absolutely incredible. And Mars is going to be around for a while, but after Mars, what are you going for next? What will be your next planetary target?
With Mars, it's something I always kind of make a particular effort with because I really enjoy observing it, and obviously it only comes to opposition once every 2 years. So, I've always enjoyed observing Mars, and I'll probably be imaging that until maybe April time. But after that, it'll go on to observing Jupiter and Saturn. I mean, Jupiter comes to a really good opposition in August. and it's actually the oppositions are getting closer now. So the planet is very large in angular size. So it's a really good time to start observing Jupiter. So yeah, it'll be onto Jupiter and Saturn in the summer. Yeah.
Oh, we'll be blown away again by those images, I'm sure. So what's your favourite feature of Mars? That was my other one tied in with Mars. What's your favourite feature you like to pull out?
That's a good question. Favourite feature, I think one of the best features on Mars is the eye of Mars, Solus Lacus, and it's a really good feature to see visually through a telescope as well, and it really does look like an eye when you get you know, even through say an 8-10 inch telescope, and you get reasonably good conditions. It does, and that feature is near the centre of the disk. It does look like an eye staring back at you. So yeah, that would probably be my favourite feature on the planet, I think.
I must try harder because I've got an 8-inch telescope courtesy of Pete, and yeah, I've not got very clear images yet with Mars, so I must just keep going, I think, when the clouds clear.
It just takes a good seeing conditions. That's the main issue when it comes to observing the planets.
I mean, I took the 10-inch. I don't often go out with a telescope, but I got a 10-inch Dob here, and I took it out about a month ago. And the scene, it was one of those nights when the scene was just perfect. And I could see features on Mars I've never seen before. All my life of observing, I'd never seen them before, and I was just blown away. But I've got no planetary imaging kit, and one of the things I wanted to do at some point is have a go at planetary imaging with a chilescope. So I'll probably talk to you about that a little bit more in depth at a later date. Yeah, so you know, it's hard for us all in the UK here at the moment to do any images, especially up north where we are. Up north, well, on the Welsh border, we got the clouds. We've always got clouds on the Welsh border. It's never any different.
And in Shropshire, it's the same. Yes,
it's just constantly damn cloudy. So I don't think I've been able to get out and see anything. Of course, with COVID restrictions now, where we are, everybody that surrounds us is under lockdown. We're not, but we can't get out. So we're in this island, Shropshire, at the moment. So you can't get out.
We are.
And
I think the UK in general is not an easy place to do astronomy from. It requires at times the patience of a saint.
One of the questions I was going to ask you is quite funny, really, because when we have people sometimes coming in, when we were doing Lock-In on the Locked-In show before we did the Zoom thing, we were having people phoning in, and they'd, you know, we'd be talking about imaging and that, and they'd always say, I do this because Damian does this. And one of the things that a few people have said, and I don't know if this is true or not, so I'm going to ask you, somebody said, I cool my telescope down by strapping cold frozen pea bags around the telescope because Damian does it. Is that actually true?
There is some partial truth to that, but I've never used frozen peas. I've actually got like those ice packs.
Yeah.
You have for the freezer. Yeah, so I've used those before to cool the optical tube down.
No, so see this folklore. You've got folklore out there about you. I mean, you could have been selling peas or something like that. It wasn't peas.
Just the trick there.
It was scraps.
This practice of cooling the tube down with ice packs is out there already. I know visual observers who use it. I've seen it firsthand. It does have some effect. You're trying to get that telescope tube to cool down and equalize with the atmosphere that's trying to look through, I guess.
Yeah. The big issue really is when you're trying to observe, say, using a large telescope, when you want to observe, say, at a time of year like April or May in the evening, when the temperature drops really steeply after sunset. So you want the telescope as cold as possible. Otherwise, you know, it just doesn't work properly. And the difference you can have between, say, leaving the telescope on the mount during the day, so it'll heat up and then cool down, and then, you know, having taken the scope off and cooled it properly, the difference is huge in the image quality.
So collimation wise, how often do you collimate the telescope? Is it something you do on a very regular basis, always checking collimation?
With the scope that I have here, because it's set up all the time, so I'm not setting it up each time, so it's left on the mount. I don't check collimation every single session if it's left on the mount, but if I'm taking it down and putting it up and putting it up again, then absolutely I would recheck it.
What I mean, I'm not going to ask you in-depth questions of how you do your image. Of course, that's personal to you. But what do you recommend any particular software for capturing, or is it something you use different ones for different occasions, if you like?
When it comes to planetary work, you're really looking at, for capturing, the fire capture is probably by far and away the most popular piece of software for using planetary cameras, and that's freely available as well. So you can just download it online, and it supports practically every video camera you can imagine. So, you know, it's a really easy way to kind of get into trying your hand at planetary. Yeah.
I mean, I tend to use, I've always just used fire capture for solar particularly. Yeah. Have you been involved in much solar imaging?
Yeah, I've done solar imaging from time to time. It's kind of something I've actually really enjoyed when I've done it. I've kind of, you know, because I've kind of concentrate so much on planets, it's kind of almost been like an occasional side interest.
Yeah.
But yeah, I've taken a few images over the years, and yeah, I've always enjoyed it. And you know, you can employ, as you say, the similar routines that you do for planetary to get some amazingly detailed images of the sun in either visible light or H alpha.
Yeah. So you go out and do talks. We know you go out and do talks because you came and talked for us at Solar Sphere, and I've seen you at other talks as well. But do you get over to do international talks very often?
Yeah, I've done several of them over the years, and yeah, they're always interesting. So, you know, in Europe and the US, places like that, and yeah, it's great to, you know, speak to audiences in different countries and kind of meet people that you know, online, or you know via email, and you get to meet them in person. It's, you know, experiences like that are really good fun.
So does anybody else want to ask Damian any questions? Gary, now being as you've just popped in.
I'll let everybody else go first. I've just joined the group, so I think there's a bit of a queue.
Yeah, can I jump
Damian,
in?
By the way.
Yeah. Can I jump in quickly for a plug for Damian? Damian, a lot of people would love to know how you process your images, capture them, process them, and produce what you do as the final results. Obviously, that's something personal, and it's your method. But you do online teaching as well, if I'm right. Yes. Could you briefly, explain where people, they've got to be a certain level, I guess, up that ladder to be able to capture the image, have a video to play with, and then your videos can help them, of course.
Yeah. I think this is something I started a few years ago now. I wanted to kind of put a resource online where, you know, people could access the material, and it kind of covers a wide range of tutorial material, from, you know, very fundamental stuff to do with planetary imaging right up to, you know, very advanced processing. And I also produced over the last several years a few DVDs, and I've transferred all of the material from those onto the online site as well. And yeah, if you visit my website at damianpeach.com, you can find the information there on it, and take a look if you're interested. You know, since it's been running in the last few years, I've had, you know, nothing but positive feedback from, you know, the membership. So yeah, it was a really worthwhile thing to do.
It's certainly going to help people get further up that ladder, I think.
Yeah.
You know, I'm actually amazed. Just some of the, I'd say the amateur images compared to yourself. You're up there at the top of the Premier League with some other the images out there. Those who are just coming in and have got up a couple of rungs into the league. They're producing images that are showing Olympus Mons at the moment because we're so close. And I'm absolutely astounded that you can actually get that with some basic imaging technique. If they could advance up that ladder a little bit more to where, you know, they can sort of, you know, get involved with what you're doing. Who knows what we could
actually,
produce?
I was actually saying to a friend of mine the other day that this Mars apparition, I don't think I've ever seen so many good images from so many different people.
Yeah. Is that because the cameras have improved dramatically with the frame rates over the last, I'm saying 5 years? Was it 2008 when we had the last reasonable apparition? I remember being at Jodrell Bank for one major event. I think that was probably the best. But cameras have improved, haven't they, with the flea and the grasshoppers and all these.
Enormously.
Yeah. So maybe that's part of it. Yeah.
And Damian's provided a lot of inspiration for people to get out there and do that too.
Yeah. But isn't Damian? I see Damian, what he does with the planetary and your lunar imaging as well, Damian, which I don't think gets much coverage. You do some amazing lunar imaging as well. What Patrick Moore did back in the 50s, the 60s, in my era, he was looked upon as the one to go to if you want to go to the moon. What craters are where, which area should we land in? Well, are they looking towards you for ideas for where Mars, where's the dust storm's going to turn out on Mars, because your imaging of Mars or the planets is as good as what Patrick was doing back in the day with his techniques.
One of the great things about kind of amateur planetary imaging these days is that it's an area where amateurs can still make a real contribution to science, in that all of these images, although they are really beautiful to look at and show lots of detail, from a scientific perspective, they're also fantastic for monitoring the weather on the planets. So particularly with Jupiter, amateur images are used by the Juno team to target features in Jupiter's atmosphere.
Incredible.
Yeah, it's absolutely fantastic. Thanks, Damian. Thanks.
Damian, do you think that the amateur planetary stuff is peaked? Because we're getting to such a point now that everyone's talking about seeing. Everyone's talking about atmospheric limitation. Their kit is no longer seems to be the problem. Have we got to a peak?
I think in terms of the aperture sizes, so, with the most experienced observers are typically using, 14, 16-inch telescopes. I think the limits of those have been reached. Yeah. And you can even see that when images are taken with larger telescopes, but, they are starting to show even more detail. So the only way images are going to improve further is by using larger telescopes. And as technology and software gets better, it will be possible to do that.
You're not saying that I can bolt some big lasers onto the side of my telescopes like they do in Hawaii and that?
I mean, I, for one, would certainly love to see some kind of adaptive optics system become, available to amateurs. I mean, that would just be, amazing.
Perhaps it will filter down in time, the technology. These things often
yeah.
Frank?
Yeah, just to sneak in here before Andy and follow up on what Simon was just saying there. One thing that I wonder about, Damian, if you see coming along, I'm a type of a guy, I'm kind of a half measures guy. I get involved with Maximum DL, kind of figure out what somebody is doing, what Adam Block is doing, and then I kind of move on. I'm just not the type of guy that takes it to the level that somebody like you or he does. But I'm interested in seeing what's going on, because I like Daz and I work with a lot of people on slew.com that are coming in, are completely novices, and like to just kind of bridge that gap between them. And they just simply, even with the telescopes we have at SLU, where they're doing simple images, people are just mesmerized by Jupiter and Saturn, what they can just do with simple shots. Are we any closer now to your algorithms being applied to an instamatic type of thing, like we're beginning to see with the unistellars and those type of scopes, where somebody can take an image and get something simply?
I think we're getting there with it. I think there's still a bit more work is needed to kind of create a really slick automated system for doing this kind of imaging. I think it's possible to take kind of fairly rudimentary images using the technology we have for kind of remote astronomy. But when we're talking about the kind of images that are done with planetary video cameras, there are all kinds of other considerations that need to come into play, because we're dealing with huge amounts of video data. I mean, from just one 2 or 3 hour session, you can end up with hundreds of gigabytes of video data, and that all has to be reduced to raw images. So, you know, we're talking vast amounts of data, for example, compared to, you know, a typical deep sky imaging run. And also another issue is the focusing. Now, with focusing, typically that's always done with planetary imaging by eye. So all the best, you know, most experienced planetary observers will focus by eye, just by judging it visually on the monitor, and just going with what looks sharpest. And this is always the way that, you know, we focused. And we've kind of not really, I don't think a great deal of work has been done in trying to, you know, test automated systems, say like FocusMax, for planetary imaging. So there's still more work to be done before we get to a point where we could do this, you know, remotely.
Yeah. Right, so I think we're going to go over to another track now, and then we'll come back to you if you still want to be around, Damian. You can hang around for a little bit longer. Yeah, I just want to welcome John into the chat group. Good evening, John, down there in Exeter, and we'll go over to a little bit of Europe and Rock the Night.
Good choice, Pete. Good choice. I just can't hear it.
Probably Jupiter.
Really?
Yeah, I do, and that's because it rotates so rapidly for a start, so your time is much more limited, and also because of the details you're looking at on Jupiter are all kind of quite delicate, low contrast details. To get really, really good images of Jupiter requires really, really good seeing. So that's that. You know, compared to Mars, which is a lot easier, because, you know, it's so much brighter, and the features on Mars are much more contrasty. It's much easier to get good images of than Jupiter, for example. But, you know, obviously when you get a great night with Jupiter, it's an amazing object to look at.
It is. I mean, I remember the first time I saw a transit of one of the moons across Jupiter, and I think I had a 4.5-inch reflector at the time, and I was amazed that I could see the shadow of the moon crossing Jupiter. I mean, it was a magical experience. But isn't it amazing how, you know, for so many of us, Jupiter is an old friend who we've been observing since childhood. You know, I started observing Jupiter when I was about 7, I think, maybe a bit earlier, with my first 2-inch telescope. I was about 7, so that was, what, 20 years ago. And it was, who sniggered? Who sniggered? That was you, wasn't it, Kat? Right, thanks. No, who your friends are, don't you? Anyway, but now, of course, we've seen it so often through telescopes, and we've imaged it, but the vision of it that we have now, thanks to Juno, makes it a completely different planet to what we thought it was.
Yeah, I mean, some of the discoveries from Juno have been really, really interesting. One in particular I liked was the measurements of how deep the Great Red Spot extends into the atmosphere.
Yeah, it goes really deep, doesn't it? Really
it goes really, really deep into Jupiter's atmosphere, which I think was perhaps not expected, because a lot of the reddish colour that you see with Jupiter's Great Red Spot is high altitude clouds.
Yeah.
But yeah, that was a particularly interesting discovery.
And some of those smaller storms that to Jupiter's cameras look really dark.
Yes.
And they are, you know, they look like mini black holes in the atmosphere of Jupiter.
Yeah.
You know,
and some of the real spectacular close-ups of vertical clouds where you can actually see the shadows cast by the clouds themselves, and that is really amazing to see.
Like they're like the ice clouds on Neptune, the ones that Voyager took, where you can see the shadows. They're just stunning, absolutely
amazing.
Stunning. Yeah, and of course, do you see the Cassini ones of the ice towers in Saturn's moons? And what were they? 15 kilometers high. Some of them pure towers of ice sticking up out of the rings. But the shadows, it's amazing.
Yeah,
I miss Cassini. I really miss Cassini.
Yeah, I do as well. Some of the imagery returned from Cassini was just incredible.
We need to go back.
Yeah.
Damian, sorry, Andy.
No, go on.
Yeah, Damian. Can you remember the first astro image that you took, whether it be deep sky or planetary, and do you still have that first image?
I can remember my first Jupiter imaging session. When would that be? I think it was 1997. I first attempted it, and I remember it vividly because it was just so utterly disheartening. And I'd looked at images at the time, and I thought, wow, you can really start to get some good details, using these CCD cameras. So I've got this camera, and I've hooked it up, and I was just like, God, I can hardly see anything. What on earth's going on? And it suddenly kind of dawned on me at that point that this was going to require a lot more effort than simply attaching a camera to a telescope. But yeah, it was enough to really kind of spur my interest.
I think my first wow moment with Jupiter, with imaging, was I used the security camera, a monochrome black and white camera, security camera. And I thought, visually we use filters, yellow filters and blue filters to enhance various detail. Yeah. I think I'll put a filter on. I was involved in photography and daylight imaging, normal stuff. And I thought, well, I'll put a filter in as you would do for any imaging. And I put a blue filter in. Wow, those belts jumped out, and absolutely stunned. And I recorded those, and then literally frame by frame stacked them in. I think it was Reggie Stack's 1 point, whatever it was back then, and it still produced a reasonable image. And I was just stunned. So basically, yeah, you've answered the first part of that question. The second part was going to be when you first got to the point where you could actually pick out detail on the Jovian moons. I mean, that in itself is just absolutely amazing. To actually see detail in the moons of Jupiter.
Yeah. I remember when that first kind of started to become possible, and it was right at the end of the 1990s. There was an observer in Florida that he took a few images of Jupiter at the time, and they clearly showed a feature visible on Ganymede. And those are the first images that I remember that actually showed definite detail on one of Jupiter's moons. But, since that time, it's almost become commonplace these days to record, details on Ganymede, for example. Even when the seeing is just kind of average, you can record details on it now, which, when I think back to then, it's remarkable how far things have progressed.
Yeah, it's actually stunning. I just think the way things have improved since the 1990s, 10 years or so. It's
absolutely. Amazing, absolutely amazing.
Damian, how have you coped with the sort of moniker of the best planetary imager in the world? Has it changed your life?
It's kind of, to be honest with you, something like that, I kind of, hand on heart, I do kind of take with a pinch of salt, because there are guys I look at like Anthony Wesley and a few others that are doing work I consider of every bit as good. And it's one of the great things about planetary imaging is that it's quite a close-knit community of people, in that we all kind of know each other, and we've all kind of known each other for a long time as well. So that kind of aspect of it is good. But in terms of it's led me to meet many interesting people and go to many interesting places over the years, for sure. Yeah.
Damian, can I just ask a little bit of advice on software and things? What would your best suggestions be for amateurs out there, and also on bits of equipment, best filters and things?
In terms of in terms of capturing, as I said to Pete earlier, Firecatcher is probably the best program for image capture, and you can download that freely online. When it comes to processing, the two most essential bits of software really are AutoStacker and Registax. They're used for stacking and sharpening the images. And one of the great things about planetary imaging is that so much of the software you need to do it is free. So it's really easy to get into, and even with a telescope like a C8 and a fairly modest camera and a laptop, you can start getting some really impressive images using the software that's available. So it's you know, there's really never been a better time to kind of get into, you know, if you've never tried planetary imaging, there's really never been a better time to have a go at it.
Okay.
And do you think that this trend of NASA giving, you know, making the raw data from space probes like Juno free for amateurs to play around with, I think this is an incredible new development. When you look at people like Kevin Gill,
Yeah,
what they're doing with Juno imaging and other imaging, and even some of the older Voyager imaging, they're having a second crack at, and they're producing amazing results. You know.
yeah, I've seen some of their work as well done on the old Voyager imagery, and I completely agree. Some of it is really, really impressive.
It's like seeing Voyager all over again, you know.
Yeah, it is. I agree. It's almost like the first time round we never really made the most of it.
No, that's right. Well, we couldn't because of the technology.
Yeah,
You know, it's a technological thing. It's not the fact that people weren't skilled. It's the pure fact that the technology, A, is a lot more sophisticated, and B, as you said, a lot of it is free. You know, which is truly amazing.
Frank, you've got a question there, Frank? See your hand up.
Yeah, to expand a little bit on Andy's comment before, and even Damian yourself, and the cloud tops on Jupiter, the three-dimensionality of them, and what we've seen in the ice towers. Now that I see that Brian May has come out with some work with JP is it Mezzavino and on 3D. Are you doing any 3D work or considering any 3D work with your planetary?
I've done. I've collaborated with Brian a few times in creating stereo images of planets, and also of comets as well. So we've actually done a few of those together, but I've never kind of really got seriously into it. I've been, you know, I've liked the results that have been done, but as from a personal perspective, I'm kind of, you know, I've got so many other things going on. I just kind of tend to focus on, you know, a small number of things and just concentrate on doing those. But you know, if you know, with Brian, for example, it was actually him that kind of saw the images and decided to create some stereo images himself from them and sent them to me. So you know, yeah, it's certainly interesting, some of the things that are possible with techniques like that.
David, I've just been asked by Derek, one of our regular listeners, do you do any remote imaging at all?
Yes, I do indeed, and I've done a huge amount of remote imaging over the last maybe 5 or 6 years now. So I've used the telescopes with iTelescope extensively over the past several years, primarily for imaging comets, with a great deal of success, I have to say, over the years. You know, that's been fantastic, and it was great to kind of be able to use a powerful remote resource like that. You know, it can really allow you to do things that you wouldn't otherwise be able to. And in more recent years, you know, I've been able to start imaging the planets remotely using Chiliscope. So yeah, I mean, you know, remote imaging is certainly not something I would, you know, it's something I would say is benefited astronomy enormously.
David, what about, sorry, Pete, yeah.
I just said I concur.
You concur? Good, yeah.
I
I expect you to. Yeah, I was going to say one of the new gadgets on the block is image dispersion filter. Basically, you cut out this chromatic aberration or caused by the atmosphere.
Yeah, these days we have dispersion correctors to correct for atmospheric dispersion, and these are quite widely used now by the amateur community. And another development in recent years is that cameras are now becoming incredibly sensitive in infrared. So in recent years, we've been able to actually start getting some really good images of planets like Uranus and Neptune, where before these were really difficult objects to get good images of. Now, you know, you can, you know, even with amateur-sized telescopes, you can see features on these planets now quite easily. So, yeah, I mean, you just kind of, you know, the software and cameras are just developing constantly.
I've just got a question there from John. John, do you want to ask the question yourself? He's not mute. He's muted at the moment. There we go.
Yeah, no, I'm here. I was going to ask you, Damian, because I know you. Nice to see you again, by the way.
Yeah.
Where do you think is the best place on planet Earth for planetary imaging?
Liverpool.
You got the words out of my mouth there.
Well, if there was one place you could go to set up your equipment and image, where would it be?
It'd have to be Barbados, just simply because it's. I think for people that haven't observed from somewhere like that, it's kind of hard for them to get their head around just how incredibly different the observing conditions there are from, say, somewhere like the UK. So, for example, where, like Pete mentioned earlier in the show, that he had, recently had a really good night with observing Mars. Now, imagine having maybe 4 or 5 nights a week like that. And that's not exaggeration either. It's literally almost any night you go out when the sky is clear, the sea conditions are incredible. And the views of the planets are just like, wow. You almost get, after you've been there a week or two, you start to get used to it.
I went to Barbados several times. It's unreal. I was on cruise ships though, but even on cruise ships, and the captain had a telescope, and it was an 8-inch something or another, and I was astounded at and this was even in a port where you've got lights, but yet the views of the planets were so much better than the views round near where I live in a reasonably dark sky. It's gorgeous.
I'm going to Barbados.
Barbados, beautiful.
And another great reason, it's kind of another thing that I really like about it there is it's lovely and warm at night.
Yeah.
Shirt sleeves and shorts.
That makes a big difference.
We've got a question coming from Mark Whalebone. He'd like to know, I'm going to try and read the question here. Mark Whalebone wants to know if there are possibly chemical dilemma in Jupiter's atmosphere like Venus.
That's a good question, isn't it?
So I think this is like the subject of the phosphenes, isn't it? That was detected, hopefully detected. Yeah.
I mean, nothing of that kind of nature has yet been discovered. So, I guess it remains an unknown at the present time.
I was just reading, they've discovered an amino acid in the atmosphere of Venus now.
Yes, that's right. Yeah.
So the plot thickens.
The plot thickens, eh? Yes.
I thought I heard somebody address that a little bit and said, though, that the radiation levels at Jupiter would be counterproductive to anything at all.
The radiation levels at Jupiter are extremely prohibitive to kind of life forms as we would consider them. That's for sure. Yeah. I mean, the kind of shielding they have to build into spacecraft just to allow them to operate for any kind of time period is substantial. And one of the reasons that Juno was put into an elliptical polar orbit is because of the intense radiation environment around Jupiter. But if it was to spend a long period of time just going in an equatorial orbit where the radiation is strongest, it would have been fried in no time.
Interesting. Okay, we're going to go over.
One never knows.
We're going to go over to another track now, and then when we'll come back, we'll be having a chat with Mr. John Mclean about the OSIRIS-REx missions. So we'll have a little bit of, what shall we have? I drove all night to get to Barbados.
And I got wet.
Another good thing about Barbados is the rum, if I do remember.
Not the gin cap.
I do like gin, but when in Barbados or the Caribbean,
I'm going to say, Kath, the people as well. The people are amazing.
Oh, they're amazing,
yeah.
and
John, good evening, John.
Good evening, Pete and panel. How are you all?
Not too bad. So you're welcome back to Astro Radio. You were in the Locked In shows a little while back talking about. I think we just entered lockdown at that point, hadn't we?
That's right. Yeah, we were talking about astronomy at sea, funnily enough.
Yeah, which obviously has not happened, unfortunately.
No, it's not happening at all. No.
Do you think? Have you got any bookings that you've got confirmed, or do you think this is just going to go on and on for a little while?
Well, what seems to be happening, Pete, is that I mean, I've got lots of bookings. I've got lots of contracts at the moment. I was at sea for 7 months last year, out of the year, and it was planned to be much the same next year. And the end of this year, as I mentioned to you at that time, I was supposed to be going on the Eclipse expedition to South America, and starting next week, and then going right through December. But that's been cancelled. But they keep sending me contracts, and I keep accepting them, and then they keep cancelling them. So it's you know, it's just that as the lockdown goes on, or the crisis goes on, the rules keep changing. But as I understand it, the cruise companies are all working very, very closely with people like the CDC in America and places like that, and they're working up protocols to get people back to sea. Hopefully, I've just had another one, Constellations of the Canaries, cancelled in January, but I'm hoping to get away in March, so that we've got a few trips lined up there, and they're coming in right through the year. So it just depends. That's all.
Let's keep our fingers crossed, eh? That's all we can do. That's all we can do. So, Osiris Rex. Now, this is the mission to the asteroid Bennu, and you've had some involvement. What sort of involvement have you had with this?
Well, way back in about 2015, before the launch, I was approached by a friend and colleague of mine to see if I wanted to become a mission ambassador for Osiris Rex mission, which basically working as a science communicator. It's just going and telling people about the mission and explaining the mission, and justifying $8 million basically. So I took on that role as a UK mission ambassador, and it's since that time I've given many talks about the mission, and I calculated that something like had to be, with all the talks I've done about it, definitely thousands of people that I've explained the mission to. And being in that role, I've been able to keep up with what's happening, and getting the sort of inside track on what's happening on the sample return mission. So it's been very interesting, and it all comes to an end tomorrow for me, because as soon as that sample is safely stored in the sample return unit, then my job's finished. That's it.
So I've got a few listeners of just asking some questions, especially I've got Stefan in the Russian Republic, and Tien, who's a regular listener in Japan. They don't really understand what this mission was all about. So could you explain it to them?
Right. Well, first of all, the name of the mission, Osiris Rex. The name comes from, it's made up of different words, so it's an acronym, really. It's origins, spectral interpretation, resource identification, security, and regolith explorer. So that's Osiris Rex. Now, Bennu itself is named after an Egyptian deity, and Osiris was an Egyptian deity, so that matches. So that's quite handy. So they made up this acronym to fit the name, really. You know, that was it. So the idea of the mission was first mooted in the early 2000s, when it was Lockheed that came to the University of Arizona, and they said, look, we're interested in doing an asteroid sample return mission. And they asked somebody at University of Arizona if they'd like to become the PI, the principal investigator. And eventually Dante Loretta became the PI for that mission. He still is the PI. And they said, what we want to do is go to an asteroid. They hadn't picked the asteroid at that point, and bring a sample back, something that had never been done before. Now, in those days, way back in 1995 to about 2010, we only knew about 55,000 asteroids. We'd only identified 55,000 asteroids. So they had to pick one asteroid from 55,000. And there were a number of criteria laid down. It had to be, for instance, a pristine asteroid, which means that it had to come from the early birth of the solar system. And Bennu is one of those asteroids. It's about 4.5 billion years old. So that there's many aspects to the mission, what they're trying to find out in the mission, but one of the aspects is to find out about the birth of the solar system, and even further back, the birth of the universe even. Secondly, it had to be an asteroid that was close enough to Earth that we could get to it in a reasonable time. And again, that was fulfilled the criteria. The third aspect was that one of the things that's studying with this mission is a thing called the Yarkovsky effect. The Yarkovsky effect is the effect that sunlight has on bodies in space, when rotating bodies in space. So one side of the asteroid heats up as it faces towards the sun, and as it turns away from the sun, it releases energy in the form of photons, which act like a bit of a jet, and it can actually move the asteroid off its orbit. And that's something that's very interesting for potentially hazardous asteroids, of which Bennu is one. And in fact, Dante Loretti said that this asteroid is probably the most dangerous asteroid that humankind has ever encountered. And more about that later. So the idea is to sample the asteroid. We're looking for where life came from, where water came from on Earth, and we're also looking at the effects of the Yarkovsky effect and how it can deflect asteroids or bodies in space away from the Earth. There are a number of other sub missions within the mission, if you like, to analyze the regolith of OSIRIS-REx. One of the recent things we've found is that it's dotted with pieces of asteroid Vesta. Now that's quite interesting. So it means that at some point it's encountered Vesta. There's also the aspect, you've heard of the Hayabusa missions, probably from Japan, from JAXA in Japan. And they're actually, they went to asteroid Ryugu, and they've sampled Ryugu, and they're bringing a sample back next year. Now, when we first looked at Bennu, and remember, as I said, there were 55,000 known asteroids when they picked Bennu. Imagine what it is now. By the time it launched, the mission launched in 2016, September the 8th, 2016, by the time it launched, we knew of 1.5 million asteroids. Now imagine what would have happened if they had to choose it from 1.5 million rather than 55,000. But anyway, they chose that asteroid. When we first got the images back, as the spacecraft neared the asteroid and it set up its polycam, one of the instruments on board, the images that came back were of what we call a spinning top asteroid. So it's a diamond-shaped asteroid. It has a large line at the equator. And this was very strange because Ryugu looks exactly the same. They could be twins. In fact, Dante Loretti famous said, "Are you sure we've gone to the right asteroid?" You know, but the point is, and it's what we've come to discover now, they've done some spectral analysis, and we actually think now that Bennu and Ryugu actually come from the same parent body.
That's interesting.
So that's an interesting bit. So yeah, there's lots going on with the mission. One of the very first things they found on the mission, when it was quite a distance away from the asteroid in astronomical terms, was that there's been some point in its existence it's encountered water. So there is hydrated clay on the asteroid. There is evidence that they've had water on there, and it may have been there's water on the parent body that it came from, whatever that may have been. It wasn't Vesta, we know that, because the material is different. But it's so there was water there. We know that. We also, another big shock they got was that it wasn't actually one big solid rock. It was actually many hundreds of thousands of boulders flying in formation together almost. They're all stuck together. And that caused a problem because initially the landing site had been chosen fairly early when they first got going to, or they thought they'd choose a landing site fairly easily. When they got closer to the asteroid, they discovered that there's so many rocks and boulders that the 85 foot clearance that are required for the tag sample, that's the touch and go sampler, would have to be reduced greatly, right down to about, I think it was about 25 feet or something like that, because there's just so many boulders strewn around the surface on the asteroid. So they had to change the landing site. So there's been lots of things happening on it. The mission itself had another couple of jobs on its way. It actually, the first thing it did, it went to the sun's Lagrange point number 4. As it passed there, it looked with its cameras looking for Trojan asteroids, or Earth Trojans, which are asteroids which we think exist in an orbit around the solar system, and they're very difficult to find, very difficult to see a map, if you like, their orbital path. So they turned the cameras looking for that, and we didn't find anything. We didn't find any asteroids there. But on its way, it's currently just over 2.5 billion miles away from Earth. Sorry, 200 million miles away from Earth, and it's travelled 2.5 billion miles in its journey to the asteroid. So it's been a heck of a mission so far. It's a 7-year mission, and it'll come back in 2023.
Okay, so what I'm going to do, I'm going to hand it over to the panel now to ask you any questions. Any questions, chaps and chapess?
Just a quick one, please, Pete. The actual sample will be broadcast live, I believe, via NASA TV. What time UT will that be? Because we get given the Eastern Standard Time or Pacific or Central Time, whichever it be, which always causes some confusion. Is there a GMT or a UT that we can confirm for all our listeners?
Yeah, it's going to be, it'll be transmitted live on NASA TV. So you can go online and go onto NASA TV and you get that. And it should be about 23:12 tomorrow evening, UK time.
Okay,
so that's 12 minutes past. That's when it starts, I believe. So it's, but they're going to have a program running up to the actual touch and go sampler. The touch and go sampler itself is terrifying for anybody that's been involved in the mission, the engineers, etc., because the way it's going to get its sample is different from any other sample that's been taken in the past. What it's going to do as an arm, the reticulated arm that comes out, and it, as you can imagine, the spacecraft has now got a relative speed between itself and the asteroid of 0 miles per hour. They're traveling about 62,500 miles per hour, but the speed between them is about 0. But what it has to do, it has to get down towards the surface of the asteroid. And what it'll do then, it'll put its arm out, and the sampler will just touch the surface of the asteroid. It will touch that for 5 seconds. And as it touches the asteroid, it will blow out nitrogen, which will stir up the regolith and hopefully capture some of it in the capture container. Now, we hope to get a minimum of 60 grams and a maximum of 2 kilograms. But it has 5 seconds. It's taken since 2016 to get there, and it's got 5 seconds to do this. It's quite amazing. It can do it 3 times. We've got enough nitrogen to do it 3 times, but after that, that's it. The job's over.
So this could be.
So let's hope that 5 seconds goes really well.
This could be one of the largest sample returns since the Apollo missions.
Yeah, absolutely,
Yeah.
absolutely.
So,
JAXA brought back some samples previously from what was it called? Itokama. I can't remember what it's called now. Itokanawa or something like that was the asteroid. Unfortunately, they brought about micro samples back, but there was a problem with the contamination of the container when it landed, so they were just about useless, really. This particular spacecraft, what it will do when it takes the sample, and let's hope it does get the sample, it will then immediately withdraw from the asteroid to avoid any chance of collision. And as it withdraws from the asteroid, it will begin to spin. Now, before it takes the sample, it will have also done what we call the inertial spin. Then after it's taken the sample, it'll do another inertial spin, and it will measure the inertia of the spacecraft. And that will tell us how much of a sample we've got. Then what it'll do, it will then take that sample, the arm will move up, it'll open up the sample return container, it'll put the sample inside, and then that will be sealed, and that will be hermetically sealed, whatever that is in space, and that will be brought back in 2023. The sample will come back to Earth, September the 28th, I think it is, but or 24th September. So yeah, so it's going to be. Hopefully, we'll get to 2 kilos, not the 60 grams.
How does the sample return capsule find its way back to Earth? Does it have any autonomous steering capability, or is it just, you know, pointed at the Earth roughly and fire and hope that it gets captured by the Earth's gravity? Because that seems quite an amazing feat to do that.
No, the actual whole spacecraft is coming back.
Oh, the whole spacecraft.
Yeah.
Right, I'm with you.
The whole spacecraft will come back to Earth. It'll take 2 years to come back, and then what it'll do, it will release the sample capsule, and that will come in through the atmosphere. One of the ideas with the spacecraft then, because spacecraft it will still be usable, it'll still have fuel. So what they're going to do is they're going to send it out back into space and sort of more or less park it for a while and decide if they can do anything with it. But meanwhile, it'll have ejected the sample container, and that will come down, and it's very, very robust. So hopefully there won't be any contamination there, and this will be an absolute pristine example of the early start of the solar system.
It's coming down in Utah, isn't it, if I remember rightly?
Yeah, that's the plan. That's the plan.
Yeah.
Unless Elon Musk at that time designs something that can go up and catch it or something, I don't know.
Probably. It's amazing. We chatted earlier on about this, John. It's amazing that we can launch a vehicle from the Earth, head out into space, hit a target that is moving and rotating. Whether it's an asteroid or a comet, it's just amazing that we can get that far, make contact with it, take a sample, and then get it back to Earth, hopefully safely, and examine the material from the early parts of the solar system origin. Actually, technically, is just amazing, isn't it? It just astounds me.
Again, it's you got to understand. Asteroid Bennu is only 500 meters in diameter, so that's a lot different from the comet Gerasimenko, 67P, which was much bigger. Still an incredible feat to do that.
I think it's stated as tall as the Empire State Building.
Yeah. But this asteroid is minuscule compared to that, and it is. I mean, the orbital mechanics, the mathematics involved to work it out, and of course, we had to use the planet Earth as a gravity assist as well. So after it was launched, it came back to Earth and went down around the poles, and got a gravity assist to send it out, because but that wasn't for speed, by the way, because we've actually had to slow the spacecraft down to match Bennu. Normally what you do, for instance, in New Horizons, whatever, you're trying to adjust your speed, so you're doing gravity assists to increase speed. But on this mission, the gravity assist was really to adjust the angle, because the angle of orbit of Bennu is 26 degrees off from Earth's orbit. So it had to adjust the angle so it could do the rendezvous. So that was the reason for that.
Yeah.
But yeah, incredible mathematics.
We should ask Damian, do you have any questions at all? Any thoughts on the matter?
Who?
Yeah, hang on. Yeah, it's really interesting, actually, because I wasn't overly familiar with the mission. So yeah, I've learned quite a lot. It's quite interesting to hear some of the details of it.
This one sneaked up on us, I think. I do remember the launch. I remember some talk of it, and then it sort of like went into the back of the files, and then all of a sudden it's on the doorstep. As I was saying to John earlier today, it crept up on us, and now it's here, it's happening.
It arrived a long time ago, though. So it's been orbiting Bennu for a long time.
Yeah.
It certainly has, yeah.
One of the most amazing sequences that I recommend everybody looks up is rubble actually flying off the surface of Bennu. I don't know whether you've seen that one.
Yeah, seen that, yeah.
An animation.
That was some imaging technique, that as well, because it wasn't just one image.
It was amazing, just to emphasize what a loose pile of rubble that is. Rubble actually flies off the surface and then lands again.
I'm sure Damian could get a picture of that one.
I'm sure.
It's a challenge. So, okay, Daz?
John, you were talking about the composition of Bennu, and as you said, basically it's a pile of rubble, and it's made up of all the different, as you said, pieces of Vesta have been seen on there and all that. But I understand also it's been, I think it's radar, but it's been used on it, and they found it's less dense in the centre. So is it honeycombed, or is it just rubble all the way through, do you think?
Well, first of all, Bennu is a carbonaceous asteroid, so it's mainly carbon. Now, the difference between comet Churyumov-Gerasimenko, or 67P we'll call it, and an asteroid like this is the comet actually has like almost a foam interior. So, and we weren't really expecting it to get a similar result with an asteroid. It's probably because of the makeup of it and the fact that it's come off, we think, the surface of its parent body. Whereas Ryugu, you might say its sister asteroid, which shares a parent body, we think, probably came from deeper down in the parent body. So more solid, more dense. And Bennu's a little less dense, so it's hard to say what it actually is in there, but it's probably just carbonaceous rock.
I was thinking when you said about Mr. Musk might get involved at some point in the future. I'm just reading the notes. It's possible. I'm being very careful. What a great guy. Starlink, love it. It could be rich in plutonium and gold. So there's something for mining. Now, link that in with the fact that in 2175 to 2199, it may actually collide with the Earth.
Yeah, well, that's what I said.
A chance to get in there, get some minerals, some elements.
That's what I was saying about it being a PHA. It's classed as a PHA, a potentially hazardous asteroid. And currently we have about 2,000 PHAs that are tracked by NASA. And other organizations, but mainly NASA tracks the PHAs. Bennu is one that, although at the moment it's a long way away, its orbit is predicted to cross with Earth in about 2135. Now, it will actually cross twice, but in 2135 it'll come in between the Moon and Earth. Now, given one of the reasons we're studying the Yarkovsky effect, in other words, the effect of sunlight, the heat from the sun on the asteroid and its ability to change its trajectory, is that as it comes within our sphere of orbit, if you like, there's two things that can affect it. One is gravity, of course, and the other is the Yarkovsky effect. The Yarkovsky effect takes a long, long time to happen. It'll take 100 years to knock it one sort of degree off its trajectory. But gravity, of course, is a different thing. Gravity could affect it quite immediately. And the fact is that this is such a potentially hazardous asteroid that it could quite easily impact Earth in 2135. And it's the only one that we know of at the moment that has got such a close predicted orbit. So if you're around in 2135, don't book a holiday.
I'm looking around the panel and thinking we may not have to worry about that.
You speak for yourself, mate. You speak for yourself.
Frank?
Just if anybody hasn't actually looked at that, when you talk about, it being rubble and being, I don't know if everybody has an exact idea. It'd be close to watch if you haven't seen it tomorrow night, and what some of the pictures are. Because I volunteered because I hadn't done any good shovel astronomy or painting like Simon does, and I felt kind of guilty, so I volunteered for CosmoQuest to do some of the classification of the surface as they started to look at it. And what a nightmare! What a nightmare.
Oh,
I mean, it
terrible,
literally,
terrible.
It's a
yeah,
nightmare.
I don't know, you said 25 feet. I'm surprised they found 25 feet. I mean, it is basically, so that being said, I did a number of those and it got quite exhausting to do that. But another question, two questions I guess I had. One is, you said that it's got 3 tries. So if it doesn't get this one, we're talking another month from now. It has to hang around from a month maybe or something. What kind of timeline are we got for a second try? And then I guess the other thing would be, if it is this loosened rubble in 2035, even if it does impact the Earth, are we talking, do we really understand what the physics of a impact would be that is that loose, and how, what that would actually look like?
Well, to take your first question first, the 3 attempts can be made almost immediately after each other. They'd have to withdraw and then come back in again. So it's just the amount of time it takes to do that. So they're not going to have to wait months to do it. Hopefully we'll get it first time.
Yeah.
You know, but secondly, the effect of an impact of an asteroid of 500 meters, you would be something like it would be something like 3,000 tons of TNT, something like that.
Wow.
Provide the whole state together.
How does this makeup change it though? It being so loosely compacted, does that change the
Well,
physics of it a lot?
Well, of course, then you have to call in Bruce Willis.
Well, hang on, isn't that John Mclean?
Oh yeah, that's right. Yeah.
By coincidence.
Oh, well, obviously, we don't know, do we? We don't know. I mean, it could break up. 500 meters asteroid. We've never really had one that close to Earth since the demise of the dinosaurs, really, I suppose. We have smaller asteroids. Look at things like Chelyabinsk, for instance, something, the size of a Volkswagen bus. What size that was before it came through the atmosphere, slightly bigger, perhaps. But, I mean, that could have caused some devastation if it hadn't exploded in an airburst. I mean, that would have caused some devastation. Tunguska, we've seen the devastation that an airburst there can cause for a relatively small object. Something that's 500 meters wouldn't be an extinction event, even if it stayed together. It would need to be in excess of 2 kilometers for it to be what we class as an extinction event. So really, it could cause a lot of damage. Some of the research that's being done on it, because people are looking into this already, the effects of asteroid Bennu actually impacting the Earth, and they're actually trying to work out where they would have to evacuate populations. Now, if you could imagine, in order for us to do anything about it, provided we had any mitigating spacecraft, which we don't, then we'd need about 3 years' notice. Fortunately, we've got lots of notice for Bennu, but for most asteroids, we'd need about 3 years' notice to do something. There's lots of different schemes where you can use gravity tractors and the Bruce Willis option, the nuclear weapons, which isn't really a good option. My favourite one actually is to send a spacecraft up alongside it with a big paintball gun and paint half of it white.
Simon's just put his hand up. No lead paint. Okay.
There's still no chance though with this thing being so loose that it just turns into a really cool meteor shower. We still got a problem, even though it's so loosely packed.
I think it says 40% vacuum, isn't it? It's like a Swiss cheese.
Yeah, but some of those rocks are pretty big, though. I mean, they would still impact Earth. They would end up as meteorites. They would definitely. If anybody's 2135 and you're looking for some really valuable meteorites, there's your chance.
John, getting back to this idea of having 3 possible attempts at grabbing a sample. So I'm guessing that if, for example, if the first sample got, I don't know, let's say 200 grams of material, would the plan be then to go and have another go to keep filling it up to the 2 kilogram level, or would they say, right, we've got something, we're not going to risk trying again?
No, once they've got a sample, that's it.
That's it. Yeah.
Because what they have to do is they won't know they've got a sample until they withdraw from the asteroid and do an inertia spin. Yeah. And they'll do that, and that will measure the difference in the inertia between a spacecraft with no sample and a spacecraft with a sample. Will tell us the mass of the sample. So once that's done, that's done. They wouldn't go back and get more. I suppose if they got less than 60 grams, which is that's what we're hoping for, then they could do that. But if they got 60 grams, then they won't try again.
Right. Yeah. No, understood.
Is it always going to be near that Nightingale crater? Is there just one site? They'd come back to the same place all 3 times?
Yeah, there were 4 landing sites picked, and I think Frank mentioned that he took part in the citizen science survey, because what they did when they realised that they were going to have to pick a really difficult landing site, they put out a citizen science program on the web, and they got people to actually look at images of asteroid Bennu, and they got them to classify the rocks, the number of rocks in a given area, that sort of thing, the sizes of the rocks. And that enabled us to look at 4 different landing sites, all named after birds, mythological birds actually. But Nightingale was picked as the best one. Osprey was one that they looked at very closely, and that's not a bad site as well, a sample site, but has a bit of a crater next to it. Nightingale also has a crater near it, but we're well away from that, hopefully. But Dave was mentioning about how accurate you have to be to actually rendezvous with an asteroid. Think how accurate you have to be to get a spacecraft down to an area between 15 and 25 feet. You know,
it's mind-boggling. Yeah, but the actual thing has descended down to about 150 feet on 3 trial attempts. So from that height or that altitude, we're seeing the boulders and the rocks. And I couldn't help but think of Neil Armstrong when he was landing the Eagle, and it was just a boulder field. He was trying to find a place to land. Yeah. Prior to that, it looked like a smooth terrain, but as they got closer and closer, those rocks got bigger and bigger. And this is a similar problem. How is it going to decide exactly where to swoop and take a sample?
Well, the point to remember, this is all to do with relative speeds, because remember that relative to the asteroid, they're both going at the same speed. There's 0 difference between their speeds. So they're actually moving in unison, you might say. So when it touches down on well, it's not going to touch down, but when it closes in on the sample site, it will be relatively going exactly the same speed as the asteroid.
Of course,
so at the moment, it's about half a kilometre away at the moment. But then when they get to the sample site, it'll just very quickly put its arm out, touch down, say for 5 seconds, and then off again.
It does.
Yes, John. With this exercise, this process, is this automated, or is there actually any manual control? And if there is there a delay?
Well, there's currently, because of the distance away that we are from Earth at the moment, which is what did I say, 200 million miles or something crazy like that. It's 18.4 minute delay at light speed. So that's the communication delay is 18 minutes. So to do something manually like that would be impossible. So once it's given the go signal, tomorrow morning it will be given the go signal, and from that point on, it's automated.
That's good. So Howard Wolowitz isn't flying.
Yeah. Sorry, could you say that again?
It's a Big Bang joke theory about who's driving rovers on Earth, also on Mars.
Yeah.
So how long after the sample taking, when it's done its inertial spin, how long after that will we know if it's actually got something?
Oh, very quickly. Very quickly, right. within I mean, I don't know how long it'll be before they announce it, but the mission principal investigator will know within the hour.
Oh, great! So we might, if we stay up late enough, then we might see it. Then we might get the
well, it depends whether they announce it or not. You never know what NASA's going to do, or they might announce it the next day. They might want a big, life on Venus.
Fanfare.
Well, it's a lovely birthday present for me, isn't it? This is going to be a great.
Is that a bit of a hint, is it, Andy?
Yeah.
That is fair.
Guess what tomorrow is, Dave?
We're not singing, sorry.
No, I don't want you to. Don't worry.
We don't want to, so there.
After that choir of the unholy last time.
Yeah.
Okay, so John, apart from this mission, you've been getting your observatory back up and running. Have you had any success in getting any images recently?
I've only just been doing really just testing the software, because I'm using new software now, and so I've switched over everything to Nina, the new control software, which I'm very impressed with. It's fantastic software. So all the observatory is controlled through Nina now. Nina now? That's it.
Yeah.
Nina now. And I've got some new cameras as well, because during lockdown I've just been spending like an idiot. So I've got 2 new telescopes and 3 new cameras.
What cameras have you got?
I've got an Attic 460EX. I've got the what we've got, Altair Astro GPM 3 224, and I've got I've got my Attic 314L, and I've just been trying out with a Sony A7 as well, full frame camera.
What do you reckon
So
to that?
I've got another one. I've forgotten what it is now.
What do you reckon to that?
And I bought 2 new scopes. I bought one. Sorry?
What do you reckon to that Sony? Any good?
Oh, it's fantastic. It's brilliant. Well, I was actually on a ship in Norway with Alan Wallace, who I'm sure a few of you know.
Yeah.
He's just won Sky Landscape Photographer of the Year yesterday. Well done, Alan. And we were doing the Northern Lights cruise, and he put me on to this Sony A7 series of cameras, and they are extremely good for noise. You know, you're getting up to 135,000 ISO, you know, and you're getting little noise, you know, but it's a fantastic camera. I've taken some great pictures of the night sky with that. It's the best full frame camera I've ever used, so I like that. But I've been attaching them to, I bought 2 new scopes as well, so I bought 127mm triplet Apple and 150mm refractor as well. And they were a bit heavy, so I bought a new mount. so you buy one thing, you have to buy something else. So they all got a bit crazy.
John, you're still doing radio work for the radio observing the meteors?
Yeah, we've got well, currently the Orionids is peaking on tomorrow night and the next day.
Yeah, for Andy's birthday as well. Yeah.
Cool.
Yeah. So we're doing the radio network. We've got this what we call the spam network, the radio detections. We're doing that, so we still get that. You get that on Marriott Astro, I think it is, on the website. You can see the live detections, or you can go on my website, exeterobservatory.com, and you can see the live radio detections. But also we've got the UK Meteor Monitoring Network. We have the cameras all around the UK, and providing the sky is clear enough, you'll get on our website, UK Mon. You'll get pictures of the meteors as they're captured throughout the night. That's on 24. That's on every night anyway. So you can go on the website anytime.
Regardless of the weather, the radio detection will pick them up anyway.
Oh yeah. That's the great thing about the radio detection. We're using a radar in France, the Graves radar in France, which is actually a radar designed to detect space junk, and we're jumping onto the back of that radar beam. And as an ex-radar engineer, quite like the idea of that. And so we're jumping onto the back of that, and we, as the meteors come through the radar beam, we get an ionization signal.
Yeah.
And we pick that up in software and we display it in a 3D image to show detection, which is it's quite nice, all pretty colours.
Yeah, I do recall.
And
sorry, John. I was going to say, I think about 2-3 years ago, the Graves engineers, let's say, the service engineers, decided to shut things down to do some service work at the peak of the Perseid meteor shower. Just by coincidence, they used that date. And, you know, is that a coincidence?
I don't think it was a coincidence. I don't think it was.
They said it was booked in advance, but
no,
It was the French. It was return from Brexit.
Oh. Politics, mate, politics. Whoa.
Don't start me. Don't start me.
It's all astronomy now. Let's keep the astronomy in the theme here.
Been told to zip it. Damian, what sort of cameras are you using?
I've kind of got a variety of video cameras. So I've been using the ZWO series. There's a new one that came out recently, the 462, which is really sensitive in the infrared. So that's been quite a revelation, actually. Just how sensitive it is. You know, for imaging Jupiter through special filters like methane band, which focuses on a very specific emission line in the infrared. It's just kind of almost revolutionised being able to photograph Jupiter in that way. So yes, there's, as I mentioned earlier, cameras are just kind of, camera technology is just developing all the time.
It's amazing.
Yeah, it is.
Damian, can I just ask, have you had any use with the Altair 294C for planetary?
I've not used the 294C, as most of the cameras that I've used are always, although the vast majority of them tend to be mono cameras. But this new one that I just mentioned, the 462, is actually a colour camera.
Yeah. Very good.
Okay, well, what I'm going to do, I'm going to go over to another track. We'll come back to the panel for the last 5 minutes, and then we'll be saying goodnight, sadly. But we'll have a little bit of Kinks and Supersonic Rocket Ship. Gives you a break.
I like that track as well. I can't hear it.
That's not a real expensive camera either, though, Damian, is it? It's not.
No, it's not. No. But the kind of vast majority of cameras that you use for planets are really low cost. I think a lot of people are quite surprised by that when they first become aware, because they kind of immediately assume that to take great images you need to spend like 5,000 or 10,000 on a really really fancy camera.
Can I make a quick confession here? You remember the Toucan Pro?
I do indeed.
Yeah, fantastic. When that came out, wow, that made some difference to lunar and solar and planetary imaging. Yeah. A friend of mine was working on the Falk's telescope, and we talked about the technique of taking an AVI and processing it with Registacks, and well, I don't think AstroStack it wasn't out then. It was Registacks, and he said if we get a chance, I'll grab a moment and put the Toucan on the end. I think it might have been the 2-meter telescope, and he grabbed about 30 seconds of AVI of Saturn, and all I've got is a slight part of the disc or the globe and its ring, just a little bit of the ring. And there wasn't enough frames to do much with the Registacks. Maybe AstroStack might do something with it, but just amazing the image scale of that telescope on a little chip like that. Totally wrong. And when you think about the time, it was downtime, it was engineering time, and it was a case of, well, let's just bang it on quick. There we go. And I just love the fact that Toucan went on me. But there you
go. Somebody like Dave and I that have been working in the medical field for a long time, it's amazing. Something you look at like this camera for $399. I can assure you that him or I may have put this on a cath lab system 20 years ago for $39,000, $40,000, $50,000. And to see it come down to something.
If we mention the names, we're not on air, are we? So we're okay. Let's say Draeger and Siemens, Philips.
There you go.
Yeah. I remember photo multiplier tubes getting thrown out. And I thought, well, if it's getting thrown out, can I have it? And I thought, I'm sure I can use this to do some, incredible star observations. Never ever got anywhere with it. I think it just collected dust or ended up in a skip somewhere.
Was it a used teabag or an unused teabag?
Oh, it'd be unused. If it's English astronauts on board, Tin Peak would never use a used teabag.
No,
that'd be fresh. So yeah, hope anyone else got any comments? This is getting silly now.
Can I actually have a bit of astronomy news?
I don't think so.
There's a sunspot.
What?
No. What?
No.
We're in a minimum.
Even on white light, you can see a sunspot now.
What's John going to say
get
about
out there
that?
and actually use your Herschel wedges, your white filters. You can see a sunspot. We haven't seen them for
Right.
Thanks, I'll have a look. Great.
How do you see? I mean, all we got's cloud.
Yeah.
Right, for finding that leak on the space module, Derek has said, get someone to smoke a cigar inside and someone to suit up and go outside to look for the smoke.
That might work.
Now, that would work in a Bruce Willis film, wouldn't it?
Definitely.
That's it. You just go outside and see where the smoke's coming from.
Anyway, guys, I want to thank you all for tuning in tonight. Thank you all for being in, the usual panel members, and thank for our two guests, Damian and John, tonight. It's been great having you on Astro Radio, and I hope you come back. Well, as I say, we do this every Monday, Thursday, and Saturday, so you're welcome just to click on the link. It's the same link every time. Just pop in and join in the chat. It's usually... If you joined in a few days ago, we had Stephen Ramsden from Charlie Bates, and we spent most of the night talking about Klingon warbirds and Romulan.
It was more sci-fi than astronomy, but it was fun.
It just it just goes where it goes. That's the idea of this.
That's it, yeah. No script, just go for it.
So anyway, thanks for being on the show tonight. Really appreciate it. And we're going to go out tonight with Ray Davis and Mumford and Son and Days This Time Tomorrow.
Cool.